let's take a look at limits. So let's consider the following linear recurrence relation. So here we have un plus 1 equals 2un of 4 with our initial value equaling 3. So if we look at it, our initial value is 3. Our next term is going to be 10, then 24, then 52. And if we keep going, our 10th value here, U10, is going to be 7,164. U20 is going to be even larger. So what we can say here, as our n value is increasing, so as n tends to infinity, so the n value being this value here in the un plus 1 or un, so as n tends to infinity, then our current term also tends to infinity, or also gets larger. Now we say the sequence diverges. So let's look at another one. So here's another recurrence relation where it is 0.5 un plus 4 with initial value of 3. So let's look at the first few terms. U0 is 3, U1 5.5, U2 6.75, U3 7.375. Here we have U10. Next value, let's check U20. So we know see U20 is going to 7.999. Now if we kept going, so as our n value tends to infinity or gets larger, we can see that our current term, our un, is tending to 8. So we say this sequence here converges to a limit of 8. Now if we look at this graphically, we can see, looking at the recurrence relation, whether there's a limit or not. So here are two recurrence relations. Our first one being un plus 1 equals 2un plus 3, and our initial value is 5. And then our second recurrence relation, un plus 1 equals 0.5 un plus 3. Again, that should be initial values 2. So they give us these two sequences separately. But you'll see if I graph this first one, as my n values are getting larger along the bottom, my current value, right, or the terms of my sequence, are just getting larger and larger and larger. They'll just keep going. Whereas in the second graph here, as my n terms are getting larger, my un, my current term, is going to be getting closer and closer and closer and tending towards the limit of 6. So this is what this would look like graphically. So these terms on the left side are divergent, meaning not coming together. The gap between the numbers is getting bigger and bigger and bigger. There's no limit. Whereas on the right-hand side, the terms are convergent, meaning the terms are coming together towards one value, or they're tending towards a limit. So, in conclusion, a linear recurrence relation converges to a limit if, when we look at this, if our a values, the value in front of un, is between -1 and 1, and if it is a value is less than -1, or our a value is greater than 1, we can say the sequence diverges. So we're looking at this value, this a value in front. Now, one thing we'll note, that if it's converging, so let's say if a was 0, right, if a was 0, then really here we wouldn't have a next term. So that is something to consider. Now, let's take a look at our limit formula. No, we're going to look at other factors first. So, some other factors to consider. So let's think about if I'm changing b. So here we've seen this example here where we have our limit converging to 8. So let's compare this new recurrence relation with our first one. So we changed b. So here you see in number 1 we had 4 as our b value, and here we have 10. So what happens in our recurrence relation, you can see, taking a look as my numbers get larger, or my n tends towards infinity, right? This is clearly heading to a limit of 20. Now in conclusion, what we can say is that if our recurrence relation converges to a limit, then changing the b value changes the limit. So you notice our a value is the same, but our b value has changed. They both still converge to a limit. However, we've changed the b, so the limit changes. Let's take a look at another factor. So we're going to change the initial value now, and we're going to compare this with our first equation here. So I still have 0.5 as my a value. I have 4 as my b value, but I'm going to change my initial value to my u0. So when we look at this recurrence relation, have a think about what is happening. So u20. Now again, we can see that this is heading to a limit of 8. So what we can conclude is essentially, if our recurrence relation is converging to a limit, then changing u0 does not affect the limit at all. So they both converge to a limit of 8. So, to the limit formula. So let's take a quick look at a short proof. Now, suppose a limit exists for the recurrence relation that we have here, un plus 1 equals a, un plus b. Now, let the limit be L, right? Now, since the limit as n tends to infinity, so as n is getting larger and larger, our current term, un, equals L, then, if that's the case, then the limit as n tends to infinity of our next term, un plus 1, will also equal L. So knowing this, what we have here is if they're both tending towards L, so un is tending towards L, then we will replace un with L. And if un plus 1 is also tending towards L, we replace that with L. And then we can do some rearranging to find L, because we want L to be our limit. So we'll rearrange. I'll subtract AL from both sides. I'm going to factorize out L on this left-hand side. So we factorized out L as my highest common factor. And then I'm going to divide both sides by 1 minus A to get L on its own. So right here, this is your limit formula. L equals B over 1 minus A. Now, one thing to note, that this is not on the formula sheet, and you will need to memorize this limit formula for recurrence relations. So let's look at a couple of quick examples. So first example, we want to find the limit of un plus 1 equals 0.2 un plus 12. One thing you'll see at the bottom, note that when using the limit formula, you must state that a limit exists since a is between -1 and 1. So you need to state that as a fact. So here, well, let's look. Is there a limit? Well, let's look for our a value. Our a value is 0.2. That is between -1 and 1. So a limit exists, since 0.2 is between -1 and 1. So because of that, we can take our formula and we can substitute in the values. So our a value is 0.2. Our b value is 12. So I'll substitute those in. And then I can just work this out. And when I do, I get my limit is 15. So this recurrence relation would converge towards 15. Our last example here. So we want to find b given un plus 1 equals negative 0.4 un plus b, where u0, our initial value, is 5. And the recurrence relation has a limit of 50. So let's take a look here. Now, what information do we have? Well, we're going to use the limit formula because we're given the limit. So using this limit formula, I know that my L is going to be 50. My B value is going to stay B. I also have my A value, my A. So we'll substitute these in. So L is 50. A is negative 0.4. Simplify this on the bottom. I'm going to get 1.4. I'm going to multiply both sides by 1.4, and when I do, I'll get my B value, which is 70. So my recurrence relation here is negative 0.4 un plus 70.